greeting to everyone, especially to every woman who are here. And I wish you an happy International Women's Day. So it's your day, and let's go ahead with the today topic that is related to biomass analysis. And the today class, what we are going to do, it's a kind of a conversation related to the potential of biomass for energy access and enhancement in the world. So let us go ahead. This is the path that we are going to follow in order to reach our today's goal. And a brief presentation about me for those who don't know me yet. I'm a professional involved in the energy sector, and I have my background in electromechanical engineering, and also I did my master's degree in renewable energy engineering. I'm really involved in rural electrification and renewable energy project. And my passion lies on things related to power grid design, energy converting systems, and battery energy storage system, and renewable energy integration. So in today's class, we are going to see how we can think about a new alternatives, or not new, but an alternative that not everyone is considering. The fact is, due to the population growth and the increasing energy demand in the world, and also due to the global challenges that is related to the actual situation of the world, the sad situation that we are facing with global warming, with climate change. So it is important to think about new approaches, new strategies, like integration of renewable energy sources, and also consideration of some other alternatives, like clean cooking, like the use of biomass, in order to increase the rate of the things nowadays. So let us see together what do we think when we are talking about energy. So talking about energy, what do we see? First of all, we see the demand, the growing demand, and this growing demand is obviously due to the population growth, the global population growth. So it is very normal, and also there is some new technologies, some some new sector that is pursuing the energy generation. Like for instance, nowadays we do have some other kind of transportation, like e-mobility. So the demand is increasing, and also due to that, it is obvious that there is a predominance of traditional fossil fuel use, because it is abundant, and also the technologies that is available for energy generation are mainly designed for fossil fuel use. So it is a thing that we can think that can be normal, and also in some countries the policies are mainly based on fossil fuel based energy generation, whereas in some other part they are trying to mix it in order to bring other kind of clean sources in the balance. It is the today's situation. So we are facing it, and also due to that, there is some kind of environmental concern that is related to greenhouse gases emission, carbon dioxide emission, global warming, things like that. So All of these things are things that we are thinking about when we are trying to address the energy landscape. And also, there are the technological progresses that are mainly related one one side. It is the user head, and at another side, it is the like the sector of production. For instance, when we are thinking about the progress made in power electronic, so it is very interesting so that we can reduce the losses due to advancement made and the converters in order to to integrate the generated energy into the grid with less and less losses. So this leads us to this point that is the energy efficiency, because sometimes it is not that we do not have the available energy, but it is the way of using it. So this could help to decrease the pressure that we are making on the energy demand. So it is important to address this concept with a good height. Also, there is the renewable energy integration that help us to mitigate the actual situation in order to decrease the fossil fuel-based energy generation share and try to increase the renewable part. And all of this lead us to some global concern like energy poverty, because remember, even when in some part of the world we can have everything, but in some other part of the world, the the situation is very sad. Therefore, it is a must, it is a need to increase energy access for everyone in the world in every part of the planet. So, if we're talking about increasing energy access, what if we try to increase it with clean energy, green energy, or with renewable energy in order to address the energy transition at the same time? So, what is green energy? Green energy is the kind of energy that can be produced using a method and a source that causes no harm to the natural environment. This is very important. Something that is causing no harm to the natural environment. So let us see this scenario. Let me pick the laser printer. Let us see this scenario where we are producing energy for the consumers, and this process we are generating at the same time electricity and carbon dioxide. So the ideal will be to produce energy for the consumers without this, like by trying to mitigate or to reduce or to eliminate. This is the idea, to eliminate completely the carbon dioxide emission that is causing harm to the natural environment. So the ideal situation would be that. So generation of electricity for everyone without emission, without side effect. So let us see in the world, how is the global energy share. Now, in this graph, we have in this axis the amount of energy generated, and the horizontal axis, we have the progress through years. So we can see that since the year 1965 to like 2 years ago, 2022, the tendencies were about the generation of energy through oil consumption. And there is a huge increasement from 20,000 terawatt hour to more than 50,000 terawatt hour, where we can see that the mix of renewable energy are below 10,000 terawatt hours since the beginning to nowadays. And it's only like and the 2012 that hydropower reached a value greater than 10,000 terawatt hours. So it was a sad situation, but we have to face it. We have to try to increase the renewables contribution in order to balance this situation. So that's why we are here in order to share some more information about biomass, what we can do with biomass, because it is important to promote the use of green energy in order to reduce the 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 emissions of harmful gases like carbon dioxide emission. So let us see in terms of electricity share. Before we were seeing global energy share, now we are seeing global electricity share. And this axis, we have it in percentage. So be aware that at every moment, the sum of all of the kind of energy should be 100%. So we can see since 1961, no, 1971 to 2019, we can see that the coal contribution was always around 40%, and the, the rest was nuclear, natural gas, renewables. But one important thing is the fact that we can see that nowadays the renewables contribution is increasing, because we can see that for the first time it is reaching a value greater than 25% of the global electricity share. But one sad fact is that nuclear is decreasing, because remember that the nuclear energy is one of the clean energy sources. So unfortunately, it is decreasing, but fortunately, the renewables are increasing. So now we have to try to reduce the contribution of coal in order to increase the contribution of renewables, and then to reduce the emissions. Now we can see how is the pattern from the 2000 to 2022 in terms of global fossil fuel share in electricity production. So let us see, in the year 2000, it was 64%. And the year 2010, it was 67%. And more recently, in 2022, it is 61%. So the fossil fuel share globally is decreasing. So this is due to the progress that we are making in the sector of renewable energy integration. So it is a very good news, but we can do better. So that's why we have to involve ourselves in order to increase that there's a good result. Now, what happened to the evolution of carbon dioxide emissions? We can see it since the year 1975. The emissions of carbon dioxide is increasing. It's increasing, it is increasing. And only in the pandemic period, we assist decreasing in the carbon dioxide emission value, but after it is still the same tendency. So that's why we say that we can do better. We can achieve more satisfactory result. Now, let us see. the real situation, because when we are talking about some numbers in terms of electricity share, we can see that the electricity share is growing, but it is not for everyone. The proportion is not as we are thinking. For instance, in this map, the brighter color mean the brighter colors, they mean that we are above 50%. The brightest color is related to area in the world where 100% of the population have access to electricity in the year 2020. And the darker color, for instance, the darkest color means that we are dealing with our area, with some regions in the world where 0% of the population have access to electricity. It is incredible. And let us see, we can see that almost all the American continent, without Haiti and Honduras, they have 100% of the population with access to electricity. And all Europe, the north of Asia, and only some countries in south of Asia have kind of 80% of the population with access with electricity. But in Africa, we can see that most of the country, they are below 50% of the population with access to electricity. So when the situation is like that, this means that we have to do something. And also, there is another consideration that we can make. We could see that the evolution of the carbon dioxide emissions is increasing. The tendency is a growing tendency. But when we are suffering from global warming, all of us are suffering. But there is a carbon dioxide emission that is due to the human activities, the energy generation activities, energy consumption activities. The result, the consequences are for all, but the uses are not, how can I say that, are not the same for everyone, because some of the region and the world have access, have 100% of their population with access to electricity, whereas some part of the world have only 40% or 30%, sometimes in some countries, 20% of the population are with access to electricity. And remember that in this context, access to electricity means that we are having an electricity source that can provide very basic lighting and charge a phone or power a radio for 4 hours per day. So we can see that this consideration for electricity access is a little bit incredible, but even this, in some countries, most of the person does not have access to this kind of electricity access. So it is a complicated situation for some region in the world. Therefore, we have to think about some alternatives. So let us see which kind of alternative do we have. For instance, we have the renewable energy. The renewable energy is defined like a kind of energy that is derived from natural sources that are replenished at higher rate than they are consumed. So remember, for instance, if we are using wood like renewable energy, if the process of forestation is not implementing at a higher rate than the consumption, it is not renewable. So to be renewable, the the consumption rate must be lower than the renew process. So it is a very important thing to notice in terms of renewable energy. And the common renewable energy sources mainly solar, wind energy, geothermal, ocean, hydropower. I think we have already seen a presentation related to the most common renewable energy sources. And also we have bioenergy, like a very important renewable energy sources that we can use, so we can take advantage of bioenergy. And bioenergy is a source of energy from the organic material that makes up plants known as biomass, which contains carbon absorbed by plants through photosynthesis. So the bioenergy, we can extract it from animal waste, ve vegetable waste, agricultural waste, forest waste, like feedstock that are not competing with agriculture for food production. Also, this is very important. So we can use all of those things like crops, like rice grain, rice straw, rice husk, in order to produce energy. Later, we will see which process that we can use in order to produce it. So all of these are included in the recycling process that is a way to convert or transform waste and discarded materials into something new in order to reuse it. So it is important to think about how we are managing waste because this is something that can cause very great harm to the natural environment because at the same time we are contributing to the pollution of soil, of air, of our environment, and also we are losing some advantages. So let us see. Sometimes what we consider as waste, we can reduce it. We can reduce the waste generation. And how we can do that? Sometimes there are some stuff that we consider as waste. We could reuse it. So if we can reuse it, it is good to opt for it. And sometimes when we cannot use it, we can process to a kind of transformation of this product in order to integrate it in the recycling process. And when we cannot, we can use it in order to produce energy, like we are using agricultural waste, forest waste in order to produce energy, or sometimes we can incinerate it in order to avoid throwing it everywhere in our direct environment. And also we can use it in order to reinforce the soil for better result in agriculture. So it is for landfill. So this is the waste hierarchy. Therefore, it is important to consider everything that we can, everything that we have in order to promote the clean energy use. Remember that in the SDG, like in the Sustainable Development Goals, the seventh goal, it is about affordable and clean energy. It is about ensuring access to affordable, reliable, sustainable, and modern energy for all, for everyone in the world, not for part of the world. So biomass can be a good option. So biomass refers to organic matter source that come from plants or animals, which can be served as a resource for energy production. So this renewable energy source can be harnessed from various biological materials to generate heat, electricity, and biofuel. Remember that the biofuel are like a kind of uh, way to store energy. So if we are not using directly the produced electricity, so we can store it for later. So it is a way of storing energy. But the biomass that come from the animals and plant waste, there are a lot of ways to extract this energy from the biomass. There is the firing process, the co-firing, the pyrolysis, gasification, anaerobic decomposition, fermentation. For instance, the firing process, it is when we are using the biomass in order to burn it directly. It may be for lighting purpose or for heat generation, things like that. And the co-firing is when we use the biomass with another combustible for energy generation. Also, we have the pyrolysis where we can take advantage of the biomass in order to produce charcoal, things like that, or gasification, like when we are producing some gases from biomass, and they can be used for clean cooking, um, for some specific cookstoves, or in aviation and transportation. So there are several there are several uses that we can make with the product of biomass. And the main products are biofuel, biodiesel, biochar, algal fuel, hydrogen fuel cells, and briquettes. And the briquettes are, they represent a very nice way to take advantage of biomass, and they can be used also in clean cooking in order to reduce indoor pollution. Remember that indoor pollution is one of the causes of death in some region, or causes of disease or morbidity in some region in the world. So what is clean cooking? Clean cooking is a process of cooking that is related to specific fuels that are defined as those that are, when they are burned, they emit a very low amount of air pollutants. And on this map, we can see are is the global configuration, like the green color refers to region in the world where 100% of the population have access to clean cooking fuels. Once again, we can see that in that configuration, most of the region are without access, without 100% of the population with access to clean fuels for cooking. Is some part in Central America, in the sub-Saharan, no, not Central America, in Central Africa, the sub-Saharan region in Africa. Unfortunately, and also some some region in Oceania, in this part of um, Asia. So the situation could be better. So we can increase the situation so that when we are seeing this map, like in 10 years, that everywhere it will be green. It will be very nice. So one of the way to process with clean cooking is using briquettes, and the process of briquetting refers to the process where we use the raw material for compress it under high pressure, and this causes that the lignin on the wood or biomass to be liberated so that it binds the material and the firm briquette. And another way, we can say that briquetting is a technique aiming at the densification of low energy density biomass resources. So the densification process, it is the very important part. So we will see this later. But remember that the biomass is not only for briquetting. We can make a lot of other things. And also, when we are talking about briquetting is not only for clean cooking. For instance, this is a situation in the United States in the year 2022, where the contribution of biomass were 5% in the energy mix in the US. And inside of there's 5%, 11% that was for residential, 8% go for electrical power, 32% for transportation, 46% for industrial, and 3% for commercial. Now, let us see the critical analysis that we can make on briquettes in order to produce it or to improve the manufacturing process. Therefore, we have to understand what is the briquette. The briquette is densified biomass. So we increase the density of the raw materials in order to be used as fuel that is offering a more ecological and energetic alternative. So, in fact, this is that we are using the raw material in order to produce something like that, that is more compacted and that can be burned so that we can extract a consistent amount of energy per unit of mass of the material. So the main composition of the briquette is the biomass itself, a binder, an accelerator, and the lubricant. The lubricant may be water, and the water can be used also as a binder. Remember that the binder is the element that make possible the bonds between the the element of the biomass. For instance, the biomass can be organic feedstock, rice straw, rice grain, rice husk, sawdust, nutshell, some forest waste, agricultural waste, wood, and so many other, like animal fat, for instance. And the binder can be rice paper, limestone, clay cement, starch, wood tar, resin, and other. And they can be organic, they can be inorganic. But remember that the inorganic produce a lot of ash, but the ash is not good for briquetting because the ashes are the incombustible part of the fuel. And when we are using organic binder, it presents better performance in terms of heating value, for instance. So let us see the manufacturing process of briquette. First of all, we have the preparation of the raw material, like separation, like drying the raw material, and then we have the grinding process. The grinding process is in order to reduce the size of the particle so that the densification can be made. Because if we are using some particle with different sizes, so it will be harder to make the densification. So it is a good option to grind the raw material, and after we'll mix it, like take the biomass, mix it with the binder and with water in order to produce something that later we can compact with a briquetting press. And after this process, we can extract it and then go for drying. The drying process is when we are extracting the water contained in the biomass, but we are not extracting the moisture completely, because if we dry it completely, it will burn very quickly. So we will not extract a good amount of energy per unit of mass. And after that, we have the control process and the storage, and sometimes we can include transportation, or sometimes we can include the carbonization, like pyrolysis. So this is an example of a manufacturing process, and this manufacturing process is only for investigation purpose. Here we have the preparation of the raw material, the mixing stage, and here we are compacting using an artisanal press, and then we are drying uh, under the sun. But the drying process can be using a specific equipment for drying, like a specific dryer. It can be a solar dryer. It can be another kind of dryer with a frost ventilation. And then we have this part of qual quality control and packaging. And the equipment to carry out this process, there are recipient grinder that is important for the size reduction, and also the briquetting press that is one of the most important thing in the process because it is the main equipment that we use for the densification, and a dryer, a container, and some other processing equipment. This is an example of a briquetting press. So here we have the chambers where we put the mixture, and then we press it so that after we extract the briquette. But this is a briquetting press that can provide us only 2 units of briquettes at each round. So the main properties of the input, we can find them using these two kind of analysis: the ultimate analysis and the proximal analysis. Let us see. The first analysis helps us to know about the elemental composition of the inputs and therefore of the briquettes, like the carbon content, the hydrogen, sulfur, nitrogen, or some other component. Therefore, it is important in order to address the ecological performance, because it is very important, because we are talking about clean energy. So we have to care about the composition so we can know what will be included in the emission. And the proximal analysis, we have to deal with the moisture content, the ash content, and the percentage of fixed carbon, and the volatile matter content. The moisture content is the percentage of water that is present in a sample. So when it is high, it prevent the combustible from burning, so it is not good for us. So we have to reduce it. And a good value for the moisture content, it is around 8% of moisture content. And for ash content, it must be under 5%, because if we have a with or high ash content and a briquette, it is a briquette that will burn badly. So we have to try to reduce the ash content. And also the fixed carbon, it is the part where, let us see here, because there's element are very important. The fixed carbon, it is the portion of the briquette that must be burned in solid state, as it remains as a residue after the volatile matter is still off, and some of moisture content and ash content, and the coal is a subtractant. So it is the solid part of the briquettes that can be burned. And the volatile matter, it is the non-water gases from a sample during its heating process. So it is the largest fraction of the biomass. So therefore, it is very important because it is the part that make the fuel easy to ignite. So this relationship is important in briquetting because in briquetting, this relation is always true. Like the fixed carbon content is equal to 100% minus this sum, the sum of moisture content, volatile matter, and ash content. And there are some other properties that are very important when we are trying to characterize the briquette. It is the shatter resistance index. So this is a property that helps us to measure the capacity of the briquette to resist at shock, to resist at impact. Because when we are making the briquette, sometimes in the storage process, the briquette can crumble. So in order to avoid them from crumble, so we have to ensure that they have a greater resistance and also the compressive strength, because in the storage process, when we are storing them, they can break between them. So in order to avoid that, we have to ensure that we have very great compressive strength. And also the heating value that is the most important in briquetting, because the heating value is the amount of energy that we can extract from the briquette per unit of mass. Okay. Now let us see what is the relationship between the heating value and the other properties that we have just seen, like the fixed carbon, the volatile matter, the ash content, and the moisture content. Look, for good heating value, we have to try to increase the fixed carbon content and try to decrease the volatile matter. Okay. And the ash content, that is the part of the composite that cannot be burned, we have to decrease it, as well as the moisture content, that is the water content of the, the fuel, we have to decrease it in order to have a good heating value. And if we are in a situation where the fixed carbon content is low, the volatile matter is high, the ash content is high, and the moisture content is high, so this will result to a situation where we are dealing with a poor heating value briquette. So in order to avoid that, we have to address this scenario instead of the second. And to perform the required tests in order to know about these properties, so there are some standards that we can use for ash content, for detecting the heating value, for the determination of the shatter resistance index. We have there's norm and standards that we can use in order to perform this test in laboratory. And finally, we had to deal with case studies where we had to develop a sustainable and accessible solution for the production of briquettes from agricultural raw materials and waste, offering an improved formula for briquetting and a simple press technology and a new manufacturing process for rural communities. And it was a project in Haiti where we found some communities that that were trying to use briquettes as an alternative to charcoal based on wood or firewood. So we noticed that the briquettes that they were using, these kind of briquette as a very low heating value. And the process, the manufacturing process was very complicated because there were they were they were struggling in order to produce a few amount of a briquette. So the research proposal was the identification of the production curves, and then make some survey, make a simple collection, data gathering in order to know more about their manufacturing process, and then make analysis of the briquettes using the previous tests that we have mentioned in order to know about the crucial properties of the briquettes, and then understand the manufacturing process. Then we will try to optimize the energy potential of the briquette and also the manufacturing process, and then propose a new technology for briquetting. So it's like we are using the Lean and Six Sigma methodology in order to improve the process in this project. So the proposed solutions was about that, like we were trying to see the composition of the briquette and then propose a new composition with new value, because the composition of the briquette have a great impact on the properties of the briquette, like on the moisture content, on the ash content, on the volatile matter content. So it is important to take care about that. So after the investigations that we made, so we could propose a new proportion for the composition and also the particle size in order to fix it, and also the density, because the density is a physical property that is very important, because we are talking about briquetting, that is mainly the densification of biomass. And also the other properties, we propose some ideal values, like for the shadow resistance index, the volatile matter, the ash content that must be under 5%, the moisture content that must be around 8%, and the heating value that must be higher than uh, 16 megajoule per kilogram, so that the project can be viable. And also, we had to think about some elemental content in order to prevent some harmful emission, avoiding indoor air pollution. So the contribution of this project, there are mainly like the establishment of the energy label of the briquette used, or the manufactured briquette in the great north of Haiti, and then propose a new formula for more efficient and more ecological briquettes, and then design a briquetting press that help them to improve the manufacturing process, because the briquetting press that they were using before, they could produce only 2 briquettes in each round, but the briquetting press that we proposed, they this press help them to produce 25 briquettes in each round. So it was a huge difference, and it was a way to make an impact in some way, like contributing to the reduction of the carbon dioxide emission, and also propose a more sustainable solution, and make them more responsible in regard to the natural environment. And also it was like a social economic stimulus, like it was a good situation for briquette producers, for vendors, and also for consumers. So it was a win-win situation, and also a great way to mitigate the deforestation, because before, most of the part of the population was using firewood or charcoal based on wood, for heating, for cooking, for some residential task, and also for some commercial task. But nowadays, and there's communities, most of them are using briquettes for this residential task. So it is a very good situation where we can use biomass, where we can use briquette for clean cooking, and for good purpose, that is contributing to the reduction of carbon dioxide emission, and to embrace the energy transition. So it was a very nice experience. So, and today's class, it is the moment for question, and to conclude. So we have to promote the sustainability and embrace the circular economy. Like we can try to reuse as it is possible some stuff in order to reduce the waste generation. And at some point, if we can use them for clean energy purpose, for clean energy generation, it will be very good. It will be very good for energy transition and the reduction of carbon dioxide emission. And it is a way to mitigate the climate change. And so thank you, everyone. If you have questions, so at the moment,
Thank you,
go ahead.
Robenson. If
And
anyone has a
happy
question,
International Days to everyone.
you can use the hand reaction or leave a comment in the chat to ask the question.
Let me see in the chat. I'm seeing in the chat for question. You can raise hand, you can ask question. My email address is Robenson J, that one, at gmail.com.
We
Go
have a
ahead,
question from
Herbert.
Herbert. Yes, let's see what they have to say.
Hello.
Hello, Herbert.
Yeah, thank you so much for the presentation.
Thank you for being here.
My question is about the biomass. It is we can see that from the presentation that the biomass also constitute things like using wood, though with other waste,
Yes.
agricultural waste.
Yes.
But this thing will still pass through the process of combustion to produce energy. So why is it counted as a renewable or a clean energy source? Because it will still pass through a process of combustion.
Okay. Yes. It is a very nice question, and thank you, Herbert. So I hope that everyone can take advantage of the question of Herbert, because his question is very nice, because if we are using some agricultural waste, we are using wood waste like sawdust, wood, in order to produce energy through combustion. His question is how this can be renewable energy sources. So let us see first of all, what is the, I hope you can still see my screen, right?
Yes. Yeah.
Okay, very good. Okay, here we are talking about the biomass. The definition of biomass refers to organic matter source that can be plants or animal that can serve as a resource for energy production. So remember, we are talking about waste. So there's waste. If we are not using them, there will be things that can be harmful for us or they can bother us. So in order to avoid leaving those waste in the environment, one thing that we can do is to use them like in this waste hierarchy. If we cannot reuse the thing, so we can proceed to recycling. Or if we cannot, we can produce energy. Okay? So we remember that they are waste. So this waste, it is like we are giving a second life to this waste. So this is a renewable process. So we are taking it back to life, or like we are taking it back to something that can be useful. And then let us see those waste, like it can be waste of animal, it can be rice husk, because when we produce rice, rice, we produce rice for nutrition purpose. But what we are heating, we are heating the rice, the rice itself, but not
Yeah.
the rice husk, not the rice brain, not the rice straw. In some part of the world, what do we do with the rice straw or the rice husk? We burn it.
Yeah.
When we burn it, this is very harmful for the environment. This is very harmful for the soil, because when we are burning it like that, it produces some kind of emission, and it is removing the carbon content of the soil. What can make the soil more productive? So this is not a good use for the rice straw. For instance, I'm only taking an example with the rice straw. Therefore, one way to take advantage of this, it is under densification, because under densification, this purpose help us through this manipulation. Remember, like when we are doing this manipulation with the properties of the raw materials, so it helps us to have a good heating value. But in order to produce energy, we have to ignite the fuel. So we have to proceed through combustion. So remember, the combustion itself, it is not the problem. It is the kind of emission that we have in the combustion that can make the kind of the type of energy that we are using clean or not. It is the type of emission. It is why it is important to see this element in the composition of the raw material. So if we have a material with high sulfur content, with high nitrogen content, so it is not a good component to include in the briquette, for instance. So we have to avoid that in order to avoid some emissions with sulfur component or with nitrogen component, things like that. And also, we have to, when we say that, we have to reduce the moisture content and the raw materials so that the heating value can be better. Remember that when the moisture content is high, when we are burning the fuel in indoor space, it will produce a lot of smoke. So this smoke is harmful for health. It contributes to indoor pollution. But when we decrease it, we can use it in clean cooking, like without indoor air pollution. So that's the point. The point it's not we are using combustion, because the combustion, it is one of the way to extract the energy contained in the combustible. Because for instance, if we have gas, if we do not proceed to the combustion, so we will not have the energy production, because we remember that by definition, the combustion is the process in which we ignite in the presence of oxygen, a fuel, so that it can produce heat, so that it can generate heat. So to generate heat, I have to proceed by combustion. But the problem is not the combustion itself, but the kind of emission that we have. And this emission depend on the raw material that we include in the briquetting process. That's why we have to take care of the properties of the raw material before. And if we are using wood, how it can be renewable? It can be renewable only if we remember this definition.
Replenish itself.
Okay, yeah, renewable energy. Renewable energy is energy derived from natural sources that are replenished at higher rate than they are consumed. So if we have a forest and we're proceeding to trees cut down for cooking, so if the rate we are proceed to the trees cut down is higher than the forestation rate, than the reforestation rate, so it is not a renewable energy sources. But if the reforestation rate is higher than the deforestation rate, so it can be considered as renewable energy. So all is in the context. So I don't know if you have more question.
Thank you. Yes, I have a question there.
Yes, go ahead.
So it therefore means that if there is more reforestation, that is if we grow more trees, as we are also cutting down to use,
Yes.
then it will the resources will be balanced. But the effect of burning, the effect of carbon emission that the trees cut down and use are producing, will it not still affect us?
I don't know if I understand well.
You have my
but
point? No. If we have the ability to grow more forests, to grow more trees, to plant
yes.
more trees, then we also cut them and use. That is, the rate of planting balanced with the rate of cutting. Then it means we can look down on the effect of the carbon emission produced by the burning of the wood.
Yes.
And call it renewable.
Okay. So I understand. So as you said, if we have a balance between the consumption
Planting
process,
and cutting,
yeah,
consumption and production.
yeah, as you said, if we have
So
a
the effect
balance
of carbon
between cutting and planting,
planting.
so these we are at the limit. The ideal will be like the planting process is higher than the process of trees cut down. So
Yeah.
this is the ideal, so that the replenishment process could be higher, so we can say it is renewable. And also
renewable.
remember that the trees have a huge contribution on the balance of oxygen
Carbon
and
emission,
carbon
carbon
dioxide,
dioxide.
because remember that they absorb carbon dioxide in order to generate oxygen for us. That's why we always say that the forests are like the pulmon of the planet. So they generate oxygen for us. So if we can avoid using wood component and the clean energy process, it will be better. That's why in my approaches, I'm always using like sawdust, like a- agricultural waste, for instance, and the project in which I was involved, we were using rice husk and rice bran in order to produce the briquettes. And also we were using waste paper in order to produce it, but not wood component. The only wood component is wood component that come from other kind of industries that are generating sawdust. So anyway,
So,
these sawdust will be generated. So we are only using it in order to enhance the burning properties of the briquette. But we were not producing the sawdust for the briquetting purpose. So that's the point.
thank you. It's still,
Thank you so much.
thank you.
Thank you. Thank you. Well, we run out of time. And remember that every day we have the same class at the same hour. Thank you, everyone, for your attendance. Bye-bye.
Bye-bye, everyone.